In 7.4, we're doing pretty much the same thing we were doing in 7.1, but this time we have two variables. So I have an x and I have a y. It says an equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables is an ordered pair that makes the equation true. So our first part here says tell whether the ordered pair is this inside parentheses, is a solution of the equation. So what we're going to do is rewrite like we always do in algebra. In the ordered pair, the first number they give us is x and the second number they give us is y. That means where I have an x in here, I'm going to put a 3. So instead of being 2 times x, this becomes 2 times 3. And where I put a y over here, I'm going to put a 6. And then I put the question mark above the equal sign because I'm asking, does this equal that? 6, does that equal 2 times 3? 2 times 3 is 6. So then I would say, yes, it is a solution. Over here, y equals 4 times x minus 3. Again, the first number in the ordered pair is x, the second number is y. That means I'm going to say 12. Does 12 equal 4 times x equals 4 minus 3? 12. Does that equal 16 minus 3? Then we would have 12 and 13. 16 minus 3 is 13. Those are not equal. Because those are not equal, I'll say no, it is not a solution. In example 2, it says the equation y equals 128 minus 8x gives the amount y in fluid ounces of milk remaining. So y is the amount that's remaining, so I'll connect those, in a gallon jug after you pour x cups. So x is how much you pour. Identify the independent and dependent variables. So if I picture this problem, as I pour milk out of the jug, that determines how much milk is left in the jug, which means my independent variable is going to be x. It's going to be how much I pour out. That's going to determine y, how much is remaining in the jug. So an independent variable I can change into anything I want to, and when I change that, it affects my dependent variable. So for example, if I wanted to say how much milk is remaining in the jug, I would first have to be able to answer, well, how much milk did I pour out? So the answer to how much is remaining depends on how much I've poured out. So that's the dependent variable. And then from there, this would be the independent variable. How much milk remains in the jug after you pour 10 cups? I'll copy my equation. We've already identified that pouring out is the variable x. So this is telling me x equals 10. Y equals 128 minus 8 times 10. Y equals 128 minus 8 times 10 is 80. And then we can line it up over here if we need to. Y equals 48. So how much milk remains in the jug? There are 48 ounces left in the jug. In example 3, they want us to write and graph an equation with two variables. So first we're just going to worry about writing it. An athlete burns 200 calories weightlifting. The athlete then works out on an elliptical trainer and burns 10 calories for every minute. Write, that's a direction word, and graph an equation, which means I'm going to have an equal sign, with two variables that represents the total number of calories burned. Alright, so the total number of calories, which we'll call C, equals the 200 they burn weightlifting plus 10 calories times every minute that they're working out. So that's this first part, the write an equation. And now they want us to graph it. If we look down here at this chart, which will not always be provided, but eventually we'll have to make our own ordered pairs, they're telling us a number to put in for M. Here's our equation right here. They're giving us the number of calories then. Well, we will figure out the number of calories that it equals, and then we'll make that into an ordered pair. So when M is 10, so I'll work these out. When M is 10, I'm putting 10 in where M is. 10 times 10 is 100. So when M is 10, C is 300. That means my ordered pair, they're telling me it should be MC, is going to be 10 because X is, or the first one is 10, and then 300. That means I'll come over here and graph 10, 300. So that's 1 point. The next one, M is 20. So 200 plus 10 times, this time we'll put in a 20. 200 plus 200. So C equals 400s. So 2400 is our next ordered pair. M equals 30. So C, 200 plus 10 times, this time we're putting in a 30. So C equals 500. So 30, 500 will be our ordered pair. We are going to draw a line through these points because any point on that line would make a data set that would work. So we will do our best to draw a straight line right through. Eventually we're going to get to problems where they don't give us this chart, and we will just have to pick three numbers that we want to put in for the independent variable, and then use the independent and the dependent variable to make some ordered pairs. In example 4, right above it, they give us the distance formula. They let us know that distance equals rate times time. And they tell us what all those variables means above example 4. Then they give us the problem, a train averages 40 miles per hour between two cities. Use a graph to show the relationship between the time and the distance traveled. So, my rate then is 40 miles per hour times the time. Down here in the table, which was already created for us, they're giving us some different numbers to plug in for the time that we've traveled and then figure out the distance in miles. So, for the first one, if my time in hours, so this is the variable t, if t equals 1, then we would have d equals 40 times 1. So my distance would be 40. That gives me the ordered pair 1, 40, which I would then come over to my graph and go 140 right here. The next one, d equals 2, t equals 2. The time is 2 hours. Distance equals 40 times 2. Distance equals 80, which will make the ordered pair 280. So over to 2, up to 80. Now we're plugging in 4 for t. Distance equals 40 times, and again I'm always coming back to this equation right here. D equals 40 times 4. D equals 4 times 4 is 16, and then add your 0 on. 160. So that gives me the ordered pair 4, 160, 4, 160. And then our last one, if t equals 6, then d equals 40 times 6. D equals 6 times 4 is 24. Put a 0 on, so 240. 6, 240. And again, we do draw a line through these. Some graphs we don't, but on these ones we will. Thank you for watching the 7.4 lesson. If you're a student watching for extra credit, the secret code word is wrestling. As always, if you have any questions, please feel free to email me.